how will I utilize DocStack to build my product? Will I use this to kind of solve the challenges that Doc has presented? And if you can give a few examples, it will be really helpful.
My name is Mike Parkhill. I am solution architect and engineering lead for some of the Doc teams. I'm personally responsible for the teams that build our APIs and our mobile applications. And I'm here today sort of to go over what we have and what we are, and hopefully give you a bit of a hands up on how to get started using our APIs. So let me start sharing my screen. We built a blockchain of our own with the whole purpose of supporting decentralized identities and credentials. I'm not going to get a lot into what those are. There's a lot of material out on the web as to what decentralized identity and verifiable credentials are, but our purpose of being is how to make it easier and consumable. Because one of the things you'll find when you get into this space is there's a lot of solutions. We're not the only ones in the space, but a lot of them are rather difficult, especially the ones that are backed by a blockchain. They insist you learn about blockchain, and you have to get deep into the space. And we're trying to appeal to a broader audience. So people who, they might know how to write REST API transaction code, but they don't need to know about blockchain specifically, or a lot about cryptography or anything like that. So we're trying to make it a little more accessible. And hopefully you'll see that as we get into this. Like I said, our blockchain is our own blockchain. We built our own. We aren't using Ethereum. We aren't using Bitcoin. We aren't using any of those things for a number of reasons. Some of them to do with performance. As you get into the bigger guys, they tend to get bogged down. They're a lot slower. And costs, the fees, as everyone knows who's played with Ethereum, the gas fees are ridiculous. So we're trying to keep costs low. We have our own chain, as we always do it. The standards that we're trying to comply with as far as verifiable credentials go are all W3C standards. So that means if Doc issues you a credential, you can go to somebody else who also supports W3C credentials and use it as well. So you're not locked into the Doc ecosystem. People who have verification tools using other providers, they can still verify a Doc credential as long as they support W3C credentials, and vice versa. We can verify somebody else's credential as long as it's W3C compliant, which makes it interoperable. And that, again, opens up possibilities to everybody, gives us a lot of opportunity, and gives our users a lot of opportunity. And the other thing we've done for most of our applications, most of our code base is open sourced. We want people to trust us, and one of the best ways for people to trust us is to show the code. So wide open, go to our GitHub. GitHub Doc Network is the name of the GitHub group, and you can go find all of our code under there. It's all open source. Our blockchain code, we have a Doc wall application that is coming out shortly. It's not open source yet, but it will be when we release. All of them, we do security audits. We have third-party independent auditors to come in. They do a security audit of it. They come back. They tell us what we're doing that we need to improve on. We improve it. They re-audit. They give us a thumbs up. We include those audits publicly in our open source repository, so you can actually go see what the feedback was. And if you want to follow up with a third-party auditor and make sure we didn't doctor it, you can do that too. Totally try to be open, try to be clear with all of that stuff. Now, as I mentioned, our blockchain is our own. Now, we decided to follow the lead of Polkadot, which obviously is a fairly well-known blockchain out there. And they've built a framework that is also open source called Substrate. And it's written in Rust. It's got quite a few adopters now. We took it, we forked it, we made some changes of our own to make it our own, but that's where it comes from. And there's no arguments there, because the amount of electricity it burns is very high. I saw a thing the other day that was quoting that the amount of electricity used to mine Bitcoin in a given year now is more than the amount of electricity the country of Sweden uses in a single year. So obviously that's a lot of electricity going on. Recently they've cracked down on it in China, so a lot of that has moved elsewhere around the planet. But it's moved. It hasn't gone away. It's moved. That electricity is still being used. So proof of work is what Bitcoin uses. It's very energy intensive, and it only gets worse because as time goes by, you have to do more and more computations to get that one transaction completed. So realizing that, our system is called proof of stake, which is a lot more energy efficient. It's a lot faster. The way instead of making something very difficult, we make it expensive for the holders to take over. So with proof of stake, again, there's lots of materials out there. You can go read about it. It's all about the people running the nodes. They have to put up a certain amount of money in the form of Doc tokens, which is our blockchain token, in order to run it. And then people have to nominate them or stake to them, as it's called. And if you don't get enough money nominated to your particular node, it won't be part of the transaction, so you won't earn any more money from it. So it's an investment thing. As you stake, as you perform transactions, you earn money back for supporting the system, keeping the system going. And we currently have 50 nodes running as part of the system, with usually between 10 and 20 other nodes kind of waiting in the wings, trying to find enough stakes in order to get promoted up into the running. And all of that, the governance is all open. Anyone can make a proposal on our chain to come and make a change. We actually recently had a proposal go through that changed the balance of rewards on the system. So every time there's a transaction, a reward gets paid. It was set as a 60-40 split, where 60% would go to the Doc Foundation, which is a sort of an open body that the whole purpose is to promote the usage of Doc in the chain and everything like that. So they need somebody for all this material, for the marketing and all the work that they do. But the people running the nodes are feeling maybe that wasn't quite fair. So instead of 60-40, a proposal was put forward to make it 50-50. Everybody voted. In order to vote, you must also put some money up on the line for your vote. And then the vote passed, it went to 50-50, off it went. And so that's the community driving the governance, and there will be other changes as well. At some point, there might be a decision to increase the number of nodes that are actively running, which right now it says 50, could go 75, could go 100. Who knows? We'll see what the community wants to do as time goes by. Now, if you're curious, I've got the link there for the code. Like I said, it's on GitHub on the Doc Network project, and just doc-substrate. And if you want to go play around and actually explore our chain, we have a JavaScript front end, which is there to fe.doc.io. And that will show you everything that's going on in rather ugly detail. It's not the most user-friendly, I'll warn you. But it is what it is, and that's where you can see it all. And that's also where you can get involved in staking and that kind of thing if you are curious with playing with that sort of piece. So that's sort of the basics of what the blockchain, the Doc blockchain is. I'm not going to go any more details than that, partly because I don't know it as much as I should probably either, but it's something for everyone to learn about if you want to and go play around. So we have this blockchain. How do you interact with it? So obviously you could interact with the blockchain directly. You could figure out, go look at our open source code and figure out what the transactions look like, and you can build your own code or use the Rust palettes or whatever to hook into it. Requires you to know a lot about Rust, blockchain, about Doc, all that sort of thing, Polkadot, which is based upon. Not easy. It's a higher learning curve. I don't claim to know it. We've got guys in the team that they know the stuff inside out, and I lean on them. But yeah, I wouldn't recommend you go that way. So we did put a next layer of abstraction on top, which is we created a JavaScript SDK that wraps all that Rust stuff and all the sort of low-level calls. But it still requires you to know a fair bit. You still need to understand the cryptography. You still have to manage all your own keys. It's a fairly heavy lift again to get there. So then we're like, okay, how can we make it even easier? How do we make it more accessible for people who don't know any of this stuff? And that's where we just have a Doc API. So again, I sort of just went over these things quickly already, but the direct access stuff is complicated. You need to understand Polkadot. You need to understand Rust. Yeah, not as easy to get into. Doesn't mean you can't, just not as easy. And we have, again, the JavaScript SDK, also very useful. You can see the open source project again in GitHub. You can go take a look at the code there, see what's on there. But the REST API is sort of what I'm here to mainly talk about and what I recommend most people start with. It's the simplest way. If you understand REST, you can probably understand what we need to do here. We try to stay fairly consistent with standards, that kind of thing, as far as it goes. Like that's a simple REST API. It handles all of the signing stuff. So when you're doing transactions, one of the big things is cryptographically signing everything you do and everything that gets sent down to the blockchain. Through the API, that's managed for you. You don't have to worry about keeping track of all your key pairs and all that kind of thing. It's just under the hood, it's done. You can not worry about it. And because of that, you don't really need to get into the details either. Like if you say, I just want to create a DID, a decentralized identity for somebody, you can just do that. You just hit our DID endpoint and off you go. You don't need to do anything more than that. Same with if you want to create a credential or whatever, you just hit our REST endpoint for that resource and off it goes. So again, pretty straightforward. Now the entry point for it is what we call our console, which again, I've got the link there. It's the console, the api.doc.io. We try and keep our naming fairly obvious. So hopefully you can predict most of what we get into on this. And when you first land there, you hit this page, and it doesn't matter if you have an account or not, you'll see the same page. We don't do passwords. We just do email links. So you come to the sign up or login, put in your email address, we'll send you an email. And in that email, you'll have a time limited link to click, which will then let you in. And once you're in, you're good to keep doing the things. So I'm actually going to jump over quickly to actually show you what the console does. We'll walk around to the console at this point. And let me just grab the right window here. There we go. So here, and this is where you'll land in once you've clicked on that link in your email. It'll bring you to the dashboard. And the first thing you'll see is this is where you keep track of the API key. So like any good REST API, you have to have an API key that goes in your header. We'll get into that in a little bit, but you need to define that REST API key. And then there's a few other things on here. One thing I'm going to point out right away is test mode. So we have a sandbox. We got production, and we have a sandbox, which we call testnet. So you'll hear me, I might at various points say mainnet, which is our production blockchain, and testnet, which is our sandbox blockchain. And so if you hear me slip those in, that's what I'm talking about. So when you're in the dashboard, you can switch between test mode and production. And you'll notice as I do this, I've got some API keys for production defined. In test mode, I don't. So the takeaway from that is API keys are specific to whether you're in test mode or your production. So you can't use the same one across the two sides. We do that for a lot of reasons. It's easier for us to track who's doing what and where they're doing it. Helps you keep track of what you're doing and make sure you're not accidentally modifying things in production if you don't mean to be. One of the big things, you'll see there's a plan and billing here because this is how we're trying to pay our bills, is through the API usage. We don't charge you in test mode. So if you're in test mode, you can kind of go at it, test what you want to do, it says as many transactions as you want. There is one asterisk because someone could say, oh, well, hey, we'll just use that forever. Well, no, we will stop you. And we do also, because we monitor this, but we also reserve the right to at any point kind of change testnet. It's our sandbox as well. So we don't guarantee that the data is always going to be permanent there. So if you need to pre-permit things, then you need to get to an actual production plan. And if we go back to production mode, you can see, these are them, $35 a month for 100 transactions, 500, 5,000. If you are going to do tens of thousands of transactions with us, give us a call. We'll work at a good deal. Makes sense for everybody. I don't imagine this group's going to be jumping into that sort of level, hopefully, but that's just that's where it's going from. So we'll go back to test mode and back to API management. So I'm going to need an API key, so I'm going to create one for when we get later into the demo here. So here's your API key. Copy it now. If you don't copy it right away, you're probably going to lose it. So, because we don't show it to you again through the dashboard. You'll see sort of the first few characters, but you can't get the whole thing ever again. So I'll copy that. The other thing I'll point out is we do allow you to restrict the IP addresses that can use that API key. So if you're concerned about someone getting hold of your API key and using it from somewhere else in the world, put in, especially if you've got a fixed IP address that works for you, throw it in the whitelist here, and then it'll be restricted. So only you can use it from your home address or from your school address or your business or whatever you're coming from. And if your IP changes because your internet provider changes or something, you can always come back in, delete the old one, add a new one. You can add as many API keys as you want. There's no real limits on it. But obviously, the more you have to keep track of which one's for what. And so I don't recommend doing too crazy on that. But we also do recommend that you, every once in a while, just change it. Just rotate it every now and then. Again, for security, if it did leak out, and if you didn't have a whitelist and it leaked out, it prevents someone from using your API key maliciously around. So right now, I'm going to leave it open. Let's see, continue. And as you can see, we can't see that key I just created, right? So I'm going to cut and paste off screen, okay, so make sure I don't lose that key. All right. So that's how you create a key, very straightforward. And you'll need to remember that as you go. Let's quickly go through the options on here. So we have the idea of webhooks. So most of this stuff, it's REST APIs. You send a request, you get a response back. And for a lot of transactions, that's all you really need to worry about. And you don't need to use webhooks at all, but it does simplify because in some of these activities, especially the ones that go to the blockchain, so when you create a DID, when you create a credential, we are actually writing something back to the blockchain. Now, blockchains, they're a little slower than your standard REST APIs are, that kind of thing. So instead of making your client wait forever, we will return a response right away. And we in that response, and we'll see this a little bit later, we'll return a thing called a job ID. So, and then we have a job endpoint in the REST API that you can hit that to sort of track what's happening. Is it done? So you could just pull that forever and sort of see, hey, yeah, that's where I'm going. And now my task is done. I can move forward. Or you can do a webhook. So when that job completes, it's going to fire off to a webhook. So a webhook is just a post endpoint. You put it in here, add an endpoint, wherever you want it to go, and we'll send a post with the body of the event that happened as soon as that event is ready. We'll also do it as a change of status, so you'll get updates throughout the process on it. There's different things you can do all of them, or you can select certain ones if you only care about things like did create. You could just choose to do a did create, and that's all. Or you can do them all. So it's all up to you how much you want to track. You can track everything or just one thing. It depends what you want to do. And if you want all, just click receive all. It'll pre-fill it all for you. So webhooks, you can track what you've been doing transaction-wise. So if you're curious how many things you've sent, how much activity you've done on the network, you can come in here and you'll see we track the activity you're doing. No, we only really track the ones we charge for. There are some transactions that we won't charge you for. Like if you want a list of the dids you created, we don't charge you for that one, and we don't track how often you've called it either. It's not overly useful. This is mainly so for your own auditing of, what do you mean that you guys are charging us for 200? We only think we did 150. Well, this is where we can go to verify that how many transactions occurred. And player billing we've been through. This is just links to our doc, which again, if you forget the URL, it's just docs.api.doc.io. Again, trying to make it really predictable. And these are originally built off of open.yaml files, open API files. So you'll see, you should recognize it fairly well. The pattern's not too different to other REST APIs you'll probably come across out there. And I won't go too much detail in here, but there's quite a bit of information in here, including this Postman collection. So if you're just wanting to dabble and you don't have an application started yet, we have a Postman collection we've created. So if you use Postman as a testing tool for REST APIs, it's fairly common out in the industry. You can pull down, just click on this link, it takes you to GitHub. You can download the file, and then you can import it. And then you can use that, and it has all your transactions set up. Where to go? So this is Postman, I've done the import already. And you can see, if you want to do a create did, here's your parameters, here's all the headers you need. We've got it set up using variables, so you can set just a global variable. So if you go to the top level of the collection, you can see in here, we've got the APIs, where you add it, adds the header. What are the variables and the values? So you can set that. So I've set this to testnet. You can set it to production if you want to use production. And this is where you'd copy that API key. So you just put that in there, put in both initial and current value, and there you go. These last four that you'll see if you import the package, we actually have some flows. So down here, we actually have a full flow. This goes through all the steps you'd want to do to get from creating initial did all the way down to verifying the presentation of a credential. We use these to pass results back and forth. So this flow can just kind of work on sort of auto-magically, as I like to say. It takes a result from one, puts it into the body of the next, and carries it on. So if you're curious what's going on, this is even just a good resource if you're writing your own code to come in and see, what do those calls look like? What does the body of a create credential look like? I'll pop in here and I'll take a look at what the create signed credential looks like and take a look at the body. And okay, that's an example of what it might look like. So it's a good resource even if you're not really using it, but it's also good just for testing. So if you are trying to build something in whatever language you've chosen and it's not coming out right, you can sort of capture what you're sending in versus what we recommend you send here, and you can test it out in here and that kind of thing. So I do recommend getting a little familiar with the Postman collection. Again, if you're not familiar with Postman, it's a great, easy tool to use for testing REST APIs, and I do recommend you check it out. All right, we'll clear that out, and we'll close the docs. And then I think it's going back to my slides for a minute. And yeah. There we go. There. We already talked about the docs because it was just nice and handy. And the Postman. So again, it's all the details there. Again, on this slide. And I think we'll be sharing these slides, or we can share these slides with everybody. Yeah, so I'll share these slides so you can see I have all these links. So you don't have to badly scribble or anything right now. So yeah, these links for the testnet and for production and all that sort of thing. So we created an API key already. Test mode I already talked about. Got ahead of myself, as you can tell. So the next thing is, along with the Postman collection, we've also created a JavaScript. We do a lot of JavaScript, if you haven't sort of picked up on that, or SDKs and things are all written in JavaScript. And that's just our familiarity, our comfort level. As time goes by, I expect we'll get customers saying, "Hey, can you do Java? Can you do .NET? Can you do Python? Can you do Ruby? Whatever." And we'll probably talk about providing some client libraries and things. We're not there yet. Right now, we've got JavaScript. We don't have a JavaScript client library yet either. But we do have some example code. So again, if you go to this open source project on our GitHub project, you can take a look at a few of it. So let me pull that up and I'll show you a quick run through of how that works. So when you clone this repository down, all these files will be here except for this .env file. So you're going to have to create this manually. And this is an important file. This is your configuration file, basically. So in it, you'll add two things. API URL is the first one. So this is which endpoint you're hitting. Again, I've got it against our testnet, our test environment, and the API key. So I'll copy in the one we just created. Save that. So now that that's set up, that's all the configuration you should have to do to run these. So the way this is set up, there's a bunch of different flows, workflows we call them. So there's an anchor workflow. So an anchor conceptually is the idea that you want to put information onto the blockchain. So this is a blob of text or something that you want permanently stored on the blockchain ledger. So you anchor it. So you do an anchor call to put it in. You can do that directly, just call the anchor endpoint itself, or you can actually, if you're creating a credential, there is an option to add the credential as an anchor on the blockchain as part of the call. It's one of the options there. Credentials is probably the most common one people will go through. So it goes through, and you have the idea for a credential. There's sort of two very important IDs involved. So who's issuing it? So that's your issuer did. And who are you giving it to, which will be the holder. So who's the person who's going to hold on to this credential after the fact. Now, technically, a holder doesn't have to have a did, but for the most part, it's a good idea. It makes it more unique, more traceable, all the kind of good stuff for the user. The issuer does have to have one, so you don't have to create one. So you'll see in our flow, we create both a holder one and an issuer one. And if you go into these, where's dids up here? You goes in, and I've created a bunch of helper little utilities because you'll find all your headers are going to look the same. So you end up in this down here in this utils stuff. So the utils, JavaScript, we're using Axios. You can use whatever REST client library you want to use, HTTP client library you want to use, but we're using Axios. It's not required. And we set some global headers. So these are, every single one's going to go through all of our text stuff, all of our requests, our application JSON, and this will add the doc API token to the header. You can also use the basic auth header. I just haven't updated it since we opened that up, but doc API token is there. And I like to log things. I'm a big fan of logging things, especially when I'm testing things. So I wrote a little helper method here that, as well as sending it, logs it. So you can see what the response was for everything and what the request was for everything. So you can feel free to check these out if you're just trying to figure out how do you make the HTTP call look? How do I build it? Look at HTTP utils in this library and you'll find out what you're looking for. Now, where was I going to go? Yeah, so another thing you can do with a credential, and this part's optional, but when you're defining a credential, so if you're going to do the same credential over and over again, whether it's a university degree or like a driver's license or whatever your credential might be, it's probably going to have a consistent schema. So a schema defines what fields are in the credential and what they look like. Is it a number field? Is it a string field? Is it an array? All that kind of thing. You can do restrictions based on how many, one, more than one, at least one, required, optional, those sorts of things can all be defined within the schema. So here we define one as part of ours, and here's a sort of, the schema is based on this body that you see here. So we've got things like, this is a degree, so what university and what was the degree and that kind of information. Now I mentioned jobs before, so this is an example of waiting for a job. So I don't have a webhook example inside this library, but I do show you how to check for jobs. So we're doing polling. So all this wait for job completion does, if I go into jobs, I think we'll find it in there. It's just a really, really cheap while loop. It's fine for an example code. If you're doing this for a production environment somewhere, you can probably find better ways. But again, trying to keep it simple, trying to make it easy for someone to understand. So you check for the job status. So back here, when we got the schema response, there's an ID in it, and this ID is actually a job ID. It's not the schema ID. It's probably poorly named. We could likely do better on that, but this is actually the job ID that you get in the response. So if we go in, we start checking for it. So, job status, get job, all it's doing is hitting our job endpoint. So again, there's a /jobs endpoint where you pass the ID as a parameter, and it comes back, and we're just tracking the status. So the status is finalized. That means it's written to the blockchain, and the job is complete. Or if it's aired out, obviously it's not going to finish properly, but it's aired out, so you can stop polling. So when you've gotten past one of those, you can say, okay, job's finished, here's my response. The reason you want to wait for the job to finish is the data may not be available for the next step. So we just created a schema. If we would try to go charging ahead and say, hey, create a credential based on that schema, but that schema is on the blockchain, then it's going to complain. It's going to say, well, I don't know what you're talking about. That schema doesn't exist yet. So you have to check, make sure the job is finished, make sure it's wrapped up before you go to the next step. So this is where checking for the jobs or having a webhook and doing it survey synchronously using a webhook. So when the webhook comes back saying the schema is done, you do the next step. So there's a couple different approaches to it. This is the simplest. The polling thing is the simplest, fastest, probably if you're short for time, like in a hackathon, it's likely the way you end up going. So we do that. We're doing a time at 2 seconds of waiting in between. You can do anything. Most of these jobs finishes between 3 or 4 seconds, but you will occasionally see one go longer. It depends on the network load, blockchain load, all that kind of thing affects it. So just sort of a heads up there that you want to make sure you're tracking that. So now going back to what we're trying to do, we've created a schema, we've waited, it's ready now. So now we can actually work with our credentials. So again, this is what we have up here. So you have to make sure you update it properly. So the data.id is the actual schema ID. So this, now we assign that to the credential body. So now that ties the credential we're creating to that schema we just created. And then the next piece is who we're giving it to, and that's the subject. So this is where I said, it doesn't have to be a did. If you've got some other ID that you want to use in your subject, you can do that. You can call it, it could be a student ID, it could be an employee ID, customer ID, whatever makes sense for you. As I said before, a did is sort of the best way to go at it, but again, it's not 100% necessary. So you set whatever your ID is, whether it's a did or something else, to the subject ID. And the subject can have other information. It can also have things like names and stuff. But again, those are sorts of details you define using your schema context. So anyway, that sets everything up. So we've got our credential set up. And then we pass it into this create credential function, which takes that credential. It also takes the issuer. Remember the issuer? This is who is saying, I gave this credential. So this is the school or the state government or whoever it is that's issuing this particular credential. It goes in, comes back as a signed credential, and the signing is cryptographically signed. So that is one of the things that makes it verifiable, is that it's cryptographically signed. And then you wouldn't normally do this right away. The verify is often an out of band step that happens later on. So once you've got your credential in here, you're kind of done. It's sort of, I've got the credential, it's a JSON blob. You can decide how you're going to disseminate to somebody. We don't currently have a credential wallet. We're building one. We look forward to having that out. Right now, our options, you'll get the JSON back. You can email that to somebody or however you want to disseminate it right now. Maybe you can import it into if they've got another wallet or whatever. That's sort of where it's at right now. Stay tuned for our wallet to come out and have credential support in it, because that'll be the big thing for us. And then the verify flow, which again, like I said, is kind of an off-band, but this is what would happen if you went to go present. So, say you're getting a new job and they ask, okay, prove to me you got that degree from that university. You'd pull out your credential and they'd go through a verify flow with it. So this is just, again, if you're writing the verifier end of this, you can follow that path of how the verify goes on and what it does. And that's essentially it. So that's sort of a very quick way of getting you from creating a DID, creating a schema, creating a credential, and all that kind of thing. And gets it out. If you do have this downloaded, you want to run them. All these workflows, just an npm run will do it. So if you do npm run credentials, it goes off and you can see it's doing its work. While it's running, I'll just quickly show you. If you're curious what all the options are, they're listed in the README or in the package JSON if you want to get into the nitty-gritty of where they are. But that's all there. So you can see it's doing its thing. And you can see in this case, it actually took about 8 seconds for the job to complete. So you can see, again, you can't just go immediately, or you don't want to do a, hey, let's sleep for 2 seconds, because that might not be enough, or it might be enough today, but not tomorrow. Or, if you try and make assumptions on how much time it's going to take, you're either going to waste a lot of time waiting because it made it too big, or you're going to rush through things and you're going to get a lot of errors because the data you're looking for isn't on the chain yet or isn't available yet. So that's why pull it or webhook it, and you should be good to go. And so in here, I believe this is our credential, this JSON block. So you could grab that, copy it out, and put it where you need to use it. And that's basically it. That's sort of all I had.
Thank you so much for this tutorial. So what sort of things you're expecting? Like, if I'm submitting a project, what would be the ideal submission thing? Like, would you like to see my code? Would you like to see me pitch it and, upload a 3-minute video on YouTube? What sort of things would impress you as the docs technologist?
I think I want to see a little bit of that pitch. I do want to hear sort of what's your idea, why is it driving you, why do you think it's important? Because I think that's a big part of it, right? Like, anybody can sort of write some code, but having the passion for why you're doing it makes a lot of sense and is important. And if you get something working, you can demo it. That's fantastic. I'd love to see demos. I do want to see the code, but I'm actually slightly less interested in the code because it's a hackathon. I don't expect hackathon code to be brilliant.
Yep.
But the only thing I'd really be double checking is, okay, yeah, they did actually use the doc APIs in the background.
Yeah, obviously.
It's not really the thing that drives me. It's more about, what problem are you solving? Why'd you choose it? How did you solve it? Can you give me a little demo? And even if it failed, and you aren't able to give me a demo, talk about what you learned and talk about what issues you ran into. And I kind of want to hear about problems with the doc API or the doc frameworks. Because it's a learning opportunity for me, because if I'm building something that the participants are having a hard time with, then I can't make it better if I don't know about it.
Yes, definitely. I understand that. Sure. So I think this was a good call. And we'll be posting this pretty soon. So let's see how the response is. And I will keep in touch with you regarding like a lot of questions that I would be getting from the participants very soon. So speak to you soon. Thank you so much.
All right. Sounds good. Thank you.
Thanks.